All right, so before we actually go through the bell work, a little bit of good news, bad news time. Good news, technology is, at least mostly, working again. Bad news is because of the technology problems, there was no way I could record the lesson yesterday. I couldn't get the notes up yesterday, but I will be putting the notes up today for what we did in class yesterday. So those are a little bit behind, again, because of those technology problems. Thank you guys for your understanding. So I won't be able to get a video up for yesterday. There will be a video up for today, and so long as we don't have any tech problems, I should be able to do videos every single day. And then notes should be going up for all those days as well. All right, let's start going through the bell work. First thing we want to do is simplify on number 1. What are some things that you guys notice that we have talked about on number 1? Yes, the top and the bottom have bases with negative exponents on them, like this one right here, this one right here, and there's even one on the bottom. So what that means is that I'm going to take the base with the exponent to the other side of the fraction. So this guy is going to come down to the bottom. Y to the negative 3, since he's already on the bottom, we're going to switch him and take him up to the top. So I'm going to rewrite that just with those in their proper places so that they don't have negative exponents anymore. All right, so up on the top, we're moving y to the 3rd. And the ones that are staying are y and z to the 5th. So y to the 3rd moved up to the top. Y and z to the 5th stayed there already. And then down on the bottom, 5 squared moved down to the bottom. X to the 3rd moved down to the bottom. And then the things that didn't move are x to the 0 and z. Hi, Breen. Put it away. 5 seconds. All right. You guys okay with how everything moved so far? Okay. Anytime you see a negative exponent, it goes to the opposite side of the fraction. If it's not a fraction, it becomes a fraction with a 1 on top. All right, now we need to look for anything that we can actually combine together. Do you guys see how I have 2 y's up on the top? This is y to the 3rd, and the one in black is y to what power? Y to the 1st power. So how many y's do I have all together up on the top that are being multiplied? 4. I have y to the 3rd, that's y times y times y, times that y to the 1st. So there's 4 of them all together. So I have y to the 4th power in my numerator. And then we also have z to the 5th up in the numerator. What about on the bottom? What can I do on the bottom? Yep, I've got those x's. I have x to the 3rd, which is x times x times x. And then x to the 0. Does that add any more? Nope. That's just going to be x to the 3rd when I put those together. Can I simplify 5 squared at all? 5 squared is the same as what? So instead of writing 5 squared, I could write 25 here, and then I still have that z down on the bottom. I see one more thing that I could simplify here. It is the z's, yes. I have z to the 5th in my numerator, and I have z to the 1st in the denominator. So that 1 in the denominator is going to cancel with 1 up on the top, which would leave me how many z's up on the top? Z to the 4th, yes. So final answer here, I'm going to have y to the 4th, z to the 4th, over 25 x cubed. Do you guys have any questions about how I knew which pieces I could combine or how we simplified? Let's look at number 2. We're going to fill in this table, and then we're going to graph this parent function. So we've got x's on the left and y's on the right. So the way we find our output, what is my base, by the way, on this function? 3 is my base. So I'm going to take that base, and we're going to take it to the power of whatever the x is at that spot. So here I have an x value of negative 2. So I have 3 to the negative 2. The next one down, I'm going to have 3 to the negative 1. We're going to do 3 to the 0 power. We're going to do 3 to the first power. And 3 to the second power. I always like starting with the positive exponents first. So are you guys okay if we start at the bottom of the table? What is 3 squared? 3 squared. 9. 3 to the first power? 3. Anything to the 0 power? 1. So looking at what I've got down there, I'm going to use that to help inform my negative exponents. What would 3 to the negative 1 be? 1 over 3. 3 to the negative 2? 1 over 9. And then we're going to go and plot those points. Negative 2, 1/9. It's going to be right here. It's going to be very, very, very close. Oh, what in the world? To the x-axis. Negative 1 1/3 is going to be just barely higher than that. It's still very close to the x-axis. And then we have 0 1, 1 3, and 2 9. Let's see, 1 2 3 4 5 6 7 8 9, right up here. What are we going to get really close to but not cross? Asymptote, which is going to be what on this one? Where is my horizontal asymptote here? Look at what those points are getting close to. 0. My horizontal asymptote is going to be at y equals 0. Horizontal asymptotes are always y equals. So I'm going to have this little invisible fence that we can't touch or cross. And when I go to trace through my points, I don't go underneath that line. It goes right above it and then through the points that we got plotted. So far, so good? All right. I want to pick back up where we left off yesterday. I'm going to have to recreate part of it, so if you weren't all the way done with where we got to yesterday, you can follow along with me. We're in the extra notes page that I had passed out, and we were on the back side on part A. And if I'm not mistaken, we had already gotten the parent graphed, correct? What are my 5 favorite x's again? Yes, negative 2, negative 1, 0, 1, and 2. What is the base on this parent function? Base of 3. So 3 to the negative 2, we just did this on the bell work, that was 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the first power is 3, and 3 squared is 9. So like I said, I know I'm playing catch up with where you guys are. So here's our parent function. And I believe we had started talking about AH and K. Is that correct? Yes? No? In this transformation down here, what is the base? 3. Has to be the same as the parent. This is the base. So where do I go looking for the A value then? In front of that. What did we say our A value was here, since I don't see anything in front of the base? A is 1. We take that A value and we multiply it to which side of our table? A value always gets multiplied to my y's. So I'm multiplying everybody here by 1. Will that do anything to these values? No. That's why A is 1 when I don't see it. It doesn't make any changes. Had we identified H already? What was our H value? -2. We looked right here. So what I see here inside the equation, it always has the opposite sign. I call it the opposite to help me remember that. So +2 is the opposite, so H is -2. And what did we say that does to our graph? Shifts it left or right. Are we going left or right with this one? Left. Since it's a negative, we're going left 2. Head up for me, dear. You need to copy this down with us. Which axis goes left and right, the x-axis or the y-axis? X-axis. So I'm going to add my h value to all of my x's. So I'm going to add -2 to each of these. Oh, I'm sorry, Carson. We are on... Oh, did I give you the extra notes sheet yesterday? Me? Yeah. Okay. Because that's what we're doing right now, is on that extra notes page. I can grab another one if you need it. Here we go. Looks like this right here. That's the review for the test. That's okay. We're on the back side right here. And then we used those after we added to get our new x's. So we did -2 plus another -2, and we got what? -4. -2 plus -1? -3. -2 plus 0? -2. -2 plus 1? -1. And -2 plus 2? 0. That's where my x's have shifted to with this left shift. I believe we left off with having the very last piece that we still needed to do. Is that correct? We've got A, we've got H. Who is this on the end? That is K. If K is -4, what's it going to do to my graph? Down 4. Which axis goes up and down? The y-axis. So we're going to add our K values to each of these y's. Since K is negative, that means I'm minusing 4 from each of these. I want you guys to grab a calculator, pass them back. Grab a calculator, pass them back. Pass it over for me. Okay, does everybody have a calculator now? Or soon to? So what we want to do over here, this is the way I want to type it into my calculator. I'm going to do the fraction 1/9. Then inside parentheses, I'm going to multiply it by my a value of 1. And then I'm going to -4 from that. if it gives you a fraction as an answer, how do you make it give you a decimal?
Arrows at the bottom.
Yep, right above the enter key. So after you hit enter, if it gives you a fraction, hit the key right above it. We want this in decimal form. We're going to have to round it because it runs off the screen. Does anybody have that value? So we're going to round it to like 1 decimal place. So it'd be negative what? Negative 3.9. If we round it to a whole number, you're right, it'd be negative 4. But we want to take it out. Since it is a decimal, I'm not going to round it to a whole number. I'll leave it like this. But I know that that's going to be really close to negative 4, right? Now I want you to do it for the next one down. So now we're just going to change the fraction to 1/3. And then inside parentheses, put our 1 and then minus 4. We're going to round this one to 1 decimal place as well. What'd you say? Super close. You just missed one little thing. Negative 3.7. This one you can do in your calculator, or if you want to do it in your head, you can. We're going to do 1 times 1 and then minus 4. 3, negative 3. Yep. And then this one down here, we're going to do 3 times 1 minus 4. Negative 1. And then at the bottom, 9 times 1 minus 4. Positive 5. These are the points that we are going to graph for our transformation. Thank you. Before I actually graph that one, though, I want to get my asymptote on here. It's a horizontal asymptote. How do I figure out where the asymptote is going to be? What do I use to figure out where that asymptote is going to be? Yes, it is our k value. It's the x-axis for my parent. This is going to be y equals whatever my k value is. What was our k value here? So y equals negative 4. So I go to the y-axis, I find negative 4, and it goes straight across here. That is y equals negative 4. All right, now I'm going to plot my points for my transformation. Negative 4, negative 3.9 is going to sit just barely above that dashed line. It's going to be almost on my asymptote, but remember, it never gets all the way to it. Negative 3, negative 3.7, it's going to be still really close to that asymptote. Then I have negative 2, negative 3, negative 1, and 0, 5. Lays along the asymptote, curves through our points, like this. What is our domain? What types of numbers are we allowed to choose for x here? All real numbers, so negative infinity to positive infinity. Our range, now I'm looking at the y values, the outputs. The lowest this graph ever goes is where? What does it not go below? Close. Negative 4. It doesn't go below negative 4. Does it ever stop going up? Nope, so I'd have an infinity here. Can we ever touch infinity? Can you touch infinity? No. Then I use a parenthesis here. Does it touch my asymptote? No, so I use a parenthesis there too. It does not touch the asymptote, so it gets a parenthesis. We can never touch infinity, so that also gets a parenthesis. All right, let's do the last one on this page, and then we're actually going to dig into your book a little bit. What is the parent function that we are supposed to graph on part B? What is the parent function? 2 to the x. This guy right here is my parent. What is the base on that parent? 2. So I'm going to use my tables. X goes to the far left, Y goes to the far right. I pick my 5 favorite x's, -2, -1, 0, 1, and 2. What's the base again? 2 to the power of x. So 2 to the -2. What is 2 to the -2? 1 over 4. What is 2 to the -1? 1/2, 1 over 2. What is 2 to the 0? 1. What is 2 to the first power? 2, and 2 to the second power? 4. So let's go graph that parent function. -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. Not going to cross the x-axis. That is always the asymptote for the parent. And it curves through those points. All right. Let's start talking A, H, and K. What is our A value? -3. How do we know that that's A and not the base? Doesn't have an exponent. The base always has an exponent on it. What's that going to do to my graph if A is -3? It's going to reflect it. That's the negative part. So it will reflect over the x-axis. That's just the negative part of the number. What does the 3 part of the number do to it? Stretches it, yes. This will be a vertical stretch by 3. How do I deal with that A value and my table? Multiply it. Do I multiply the x's or the y's? Multiply the y's. We multiply this by our A value, so I'm going to multiply all of these by -3. What is our H value? 0. Where would we go looking for H? After the exponent. So it'd be right here. H. I don't see it. So it's 0. Do I go left or right at all then? Nope. If I add H to all my x's, I'm adding 0 to all of these, which means none of them are going to move. So I could write down my new x's, same as my old x's, -2, -1, 0, 1, and 2. What's our k value? 0. I don't see k, so k is 0. I always add k to these pieces after we multiply by a. So I'm adding nothing on. Do I go up or down at all? Nope. So where is my horizontal asymptote then? Y equals 0, because it's always y equals whatever k is. So on my graph, that's going to be right here. Let's find our new y values so that we can plot this. I'm going to do 1/4 times -3 plus 0. Grab your calculators. We want decimal approximations. 1/4 times -3 plus 0. Negative, how much? I got something a little bit different, but it's very close. I got negative 0.75. What about when we do 1/2 times -3 plus 0? Negative 1.5. 1 times -3 plus 0? Negative 3. 2 times -3 plus 0? Negative 6. And 4 times -3 plus 0? Negative 12. Those are the points that we're going to go and plot now for our transformation. Negative 2, negative 0.75. So that's almost at the negative 1. Negative 1.5 will be in between negative 1 and negative 2. And then we have negative 3, negative 6, and negative 12. What are we not going to cross? Where's my asymptote? What are we not crossing? The x-axis, y equals 0. So it's going to lay along that asymptote, and then it's going to curve down through these points. What will our domain be? Negative infinity to positive infinity. All real numbers, yes. What's the lowest this graph ever goes? Negative infinity, right? Because I've got an arrow pointing down. So the lowest it ever goes is negative infinity. What's the highest this graph ever goes? 0. And we don't actually touch the asymptote, so I use a parenthesis there. When we're doing domain or range, we always start with the smallest and then do the biggest. So on range, I'm always looking at what's the lowest it ever goes, and then the second number I write down, or the second symbol I write down, is the highest it ever goes. So lowest first and then highest on my range. So far, so good? Awesome. All right, we're actually going to be in your books for the last 10 minutes of class today. And your books, for whatever reason, do not start on page 1. They picked up the numbering from first semester, so it starts in the 300s, but it's right at the beginning of the book. We're going to be on page 358, but again, this is like right at the front. 358, but it's right at the front. Help me out here. What is the a value in this transformation? Negative 1/2. That will reflect, I always say over. It's going to reflect over what? The x-axis. And it will compress by 1/2. What is our h value here? -4. Be careful here. H is the tricky one. Opposite. It is tricky. So it is -4. What will that do to my graph? Yes, so it's going to translate 4 units left. Or you could say left 4 units. It doesn't matter what order you put it in. And what is our k value? 1. What will that do to the graph? It's going to go up 1, yes. Go 1 unit up. And here they have the graph to go with it. All right. Let's look at the next example, example 3, just a little bit further down the page. This is a transformation of f of x. So j of x, which is what they have graphed, is equal to 3.5 to the power of x plus something, plus a k value. They're telling me right now that it doesn't have an a value other than 1, so it didn't stretch, it didn't compress, it didn't reflect. Did they tell me that it has an h value? No. So it didn't go left or right at all. It just moved either up or down. Where would the y-intercept be for this parent function? Where would the y-intercept be for the parent? Tell me how a y-intercept looks. What does the ordered pair always start with? Starts with the x part of the ordered pair, and it always starts with a 0. So let's see what happens if I plug 0 in the place of x. 3.5 to the power of 0, 1. So this would be the y-intercept for the parent. So it would be right here. Where's the y-intercept on this transformation? -1. So did it go up or down compared to the parent? It went down. How far down? 2. So the graph has been translated 2 units down. So what is our k value then if it went down 2 units? -2. So j of x is 3.5 to the power of x minus 2. Last couple minutes, we're going to do example number 4. I don't know if we'll get all the way through it, but we'll do another practice problem like that tomorrow as well. So example number 4. I am not going to use the way your book has it scaffolded out. We are not pulling out graphing calculators. You guys do have a little bit of room off to the left-hand side though, right? All right. So I want to talk about the big ideas here. Exponential growth can be modeled in this way. This part right here would be my base. How do I know that that's the base? Has an exponent on it, yes. The base always has an exponent on it. What is our exponent here? t. T represents time. A is going to be our initial amount, or our starting value. R is the percent of increase. So when they tell me R as a percent, I have to divide that by 100% to get just R. When they tell me R as a percentage, I have to divide it by 100% so that my percents cancel out. And then that'll leave me with just whatever the R value is. So R is the percent of increase, and we call the base here the growth factor. Base is our growth factor. So I want to talk about this one and see if we can get an equation written in this form and simplified, and then we'll shut it down and we'll finish it up tomorrow. Mr. Lopez recently won the lottery. Suppose he takes the lump sum payment and he invests $50 million into an account that yields 5% interest annually. Graph a function that models the amount in his account, then estimate the amount in the account after 20 years. All right, so we're just going to substitute in first. Guys, we still have a little bit of time. Hang with me here. So I have A of t, you should be writing this off on the left-hand side, equals A times 1 plus R to the power of t. What was the initial amount, the starting amount? 50 million. We're going to go ahead and just write this as 50, and we'll say it's in millions, rather than write out all 6 zeros afterwards. And then inside parentheses, it's 1 plus, and then I need the rate, R. What did they give me for R? 5%. They gave it to me as a percent. I can't put it into my problem as a percent. So what do I do with it? Divide it by 100%. That gives me 0.05. To the power of t. Can I simplify those parentheses at all? What happens when I add those two numbers together? I get 1.05. So what is my growth factor? 1.05 is my growth factor, yes. We will finish this problem tomorrow, and we'll do the check, going over those big ideas that we need to cover.